Hi everybody, welcome to another video in Discrete Math, section 6.4, binomial coefficients and identities. Binomial theorem. First, the definition. A binomial expression is the sum of two terms. And now we're going to raise that to some power. So each term maybe more than just x. It could be x squared 2x or something like that. Right. So before we actually go to the formula, let's just do some very basic. I just expand a plus b squared. So just multiply by itself. That gives us a squared plus ab plus ba plus b squared. Right, ab and ba is the same thing, so that's 2a squared plus 2ab plus b squared. Right? Yeah, straightforward. Of course, they're a shortcut. They multiply now that other things, but I want to do deliberately like that. You see why in a minute. Now we have x plus y, x plus y, x plus y 3 times. So that makes a cube. Now we multiply these two first. Like I said, we combine like terms and put them in order later. Now just multiply x squared all to right. X if you want to, just x squared. Actually, just keep x. I think that's even better. xy, yx, and yy. Yeah, it might look silly at first, but you'll see. And now multiply this, we have x. Just right. xy, xyx, and xyy. And then yxy, yxy, yx, and yy. It looks silly at first, but of course after that to combine like terms, this x cubed. Now if you look at and then y cubed at the end, that's easy. Now let's take a look. This term have 2x and a y, 2x and a y, and 2x and a y in some particular order, right? Let's do it by the way. Just write 3x squared y. And this 2y and an x, 2y and an x, 2y and an x. And y cubed. Right, so the coefficient is 1, 2, 1, 1, 3, 3, 1. Now, let's go to the next one. So remember, we have x and y in some certain order, right? So pretty much that's why we have in this case, because this way we do not choose anything. So the coefficient, when we look at this, we see talking about the degree, it starts from x cubed, x squared, then x to the first, and then no x. Y start from no y, y to the first, y to the second, and y cubed. So one increasing order, one decreasing order. And then the coefficient is this. By the way, this is just the same as combination of n, j. To just like how many objects do we have? Select from n. For example, here we have 1x and 2y, or 1y and 2x. Kind of same thing. That's why they are the same. Right, by the way, it is even better if we don't have to rely on that formula. We use this formula when we have to find one term, but if you want to expand, it's much better not using it at all. Actually, we might need to use that, but not going to write like that. Right. Let's say we try to expand in that. So in that case, what I would do is write the first term, decreasing power, give a lot of space in between. And then we have columns. X to the fourth, because just x to the fourth. There's nothing else. I just want to write x to the fourth. You'll see why in a minute. Now, the second term is plus 2y. I'm going to, if they're minus, take the negative with the second term. But just have 2y. So this one decreasing power, this one increasing power. Right, so this is 1, 2y, 4y squared, 8y cubed, and 16y to the fourth. Right. And then the coefficient, we actually have to use that. Use this, but not in that form. Right, so the combination 4, and then that number 0. C41, C41, 42, 43, and 44. So that's how we get the coefficient from the binomial expansion. Right. So, of course, if we want, let's say C41, for example, we hit for math. So that's C for 0. Right? Combination of 0 out 4. Right. So a better way to do this is hit math. 4, and then go to combination. But this time we choose apply for 0, 1, 2, 3, and 4. So I used open bracket, second parentheses, 0, comma 1, comma 2, comma 3, and comma 4. Close it. That's all the coefficient we have. 1, 4, 6, 4, and 1. After that, just multiply straight by column. X to the fourth, 4 times 2, so that's 8. X cubed y, 24. X squared y squared, 32. X y cubed, and 16y to the fourth. Right. So that is a binomial expansion. The first term decreasing power, the second term increasing power, and the coefficient. What we choose for is 4, and then we choose like 0x, 1x, 2x, just like this, right? So we choose 1x, we choose 2x, we choose 3x, 4x, and then pretty much that. So that is the binomial expansion. Same thing here. So we start with the first term. Decrease the power from that number. 5. Right, so. Right. So just write in columns. 5, 4, 3, 2, 1, 0. Right. So that x to the 10. That x to the 8. X to the 6. 4th. Square. 0 powers. Anything to 0 power is 1. Right, so that's the first term. decreasing power. The second term, if this minus, the minus will go with the second term, and it's increasing power. And then the combination. Later on there's another way to write the combination to use instead of the combination, but for now just use that. Right. So 5 math probability combination. Right. 0, 1, 2, 3, 4, 5. Right. And then we just multiply by columns. X to the 10 minus 5 x to the 8 y plus 10 x to the 6 y squared minus 10 x to the 4th y cubed plus 5x squared y to the 4th plus minus y to the 5th. So that is expansion, binomial expansion. Expand the whole thing. Right? Yeah, so it's not that bad. Like I said, things like column. The formulas in front with all the power and all, that's nice and all, but don't need to know that. Just work with columns. Right. Now, so that is that. Now, what if we don't want the whole expansion, we just want particular term? Well, we can also do that. Let's say this expansion, we start with 2x. Of course, we start from 25th and going down to 24, all the way down to what we want is the to the 12. Because if 2x to the 12 is like actual raised to the 12, so we want that, right? And then the second, negative 3y to 0, negative 3y to the first, now all the way to 13. Notice that the power here, when we add up, always equal to n, because one increasing, one is decreasing, one is decreasing, and one is increasing, so they always equal. If it decreased by 1, it's increased by 1. I'm not talking about the final decrease here, I'm talking about the power outside the parentheses here. They always add up to the same number, the same power of the binomial expansion, right? So that case, 12 and 13 have to add up to 25. And then of course we have the combination, 25, 0, all the way to, notice the combination, the second number is the same as the second number of the power. So in this case, 25 and 13. So we just multiply all of this together. That gives you that term. Right, so this is equal to 22 to the 12 power x to the 12. And this is negative 3 to the 13 power y to the 13. And C 25 13 there's 25 objects, and we select 13 of them. So multiply all of this together. The term that have this is just going to say it, negative 5,200,300 times 2 to the 12 times 3 to the 13 x12 y13. Right, that's a very big number, but that is the term that have x12 y13 in it. Right. Yeah, so if we want one particular term, we just need to do one particular column. Right, next, find the sixth term in the expansion of 3x plus 2y squared to the 10. Right, so 3x, one of them decreasing power from 10, and we count the sixth term. So 10, 9, 8, 7, 6, 5. 10, 9, 8, 7, 6, the fifth term. So we focus on this particular column. And then the second term, positive, so that 2y square, starting from 0, 1, 2, 3, 4. Of course, square here to the fifth. Of course, the power here add up to 10. And then C, 10, 0, C, 10, 1, and then so on. Like I said, the second number is the same as that second number. Right. Now we just do 3 to the 5th is 243. X to the 5th. 2 to the 5th, that's 32. Y squared 5 to y to the 10. And then 10. 5 to 52. And multiply everything straight. I'll multiply everything in column. Right, we have 1959552 x to the 5th, y to the 10. Right. So just if we just want one term, just focus on that particular column. Right. And then the result is, if we sum all of that up, it's going to be this. So very easy to write. Right. Think about this. If we have 1 plus 1 to the n power, and then if we use the formula, it's going to be 1 to the n minus j, or n minus k, and then 1 to the k. Notice that this one, the first one is this, the second one is that. But since 1 raised to any power is 1, so that breaks out just the sum of all the binomial coefficient is the power of 2. Right. So next, talking about binomial coefficient, there's another nice theorem about this. On the Pascal identity. So it says the combination of k, n plus 1 k is equal to n, k minus 1 k. So essentially what it does is, we have a triangle where we have 1 on the edge, and then any particular number is equal to number above it, add together, right? So to get 21, we add 2 numbers above it, 15 and 6, give it 21. We have 1 on the edge, and every number below is equal to number above it, add together. So this is Pascal triangle, and this will give us the coefficient for the binomial expansion, as you see, 1 to 1. Or in the fifth, there's 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Yeah. So Pascal triangle will give us the whole coefficient. Right. The first one corresponding to n equal to 0, n equal to 1, n equal to 2, and so on. So this is n equal to 5, the fifth row. By the way, we just look at the second, will give us the row. So 1, 5, 10, 10, 5, 1, 5 on the second of that row. So that is n equal to 5. Right. So Pascal triangle will give us another way to find the coefficient. So instead of doing the combination like this, you can just use the Pascal triangle to get the coefficient. But bottom line is, binomial expansion, it is better to write that as a column like this than to use the summation formula. Anyway, with that we finish section 6.4. Thank you for watching. See you in another video in Discrete Math.